Today we will be doing Usaco Guide, Bronze Problem, the Bucket List in the simulation category. Farmer John is considering a change in how he allocates buckets for milking his cows. He thinks this will ultimately allow him to use a small number of total buckets, but he is not sure how many exactly. Please help him out. Farmer John has N cows, conveniently numbered 1 through N. The ith cow needs to be milked from time SI to TI and requires BI buckets to be used during the milking process. Several cows might end up being milked at the same time. If so, they cannot use the same buckets. That is, a bucket assigned to cow I's milking cannot be used for any other cow's milking between time SI and TI. The bucket can be used for other cows outside this window of time, of course. To simplify his job, FJ has made sure that at any given moment in time, there is at most one cow whose milking is starting or ending. That is, the SI and TIs are all distinct. FJ has a storage room containing buckets that are sequentially numbered with labels 1, 2, 3, and so on. In his current milking strategy, whenever some cow, say cow I, starts milking at time SI, FJ runs to the storage room and collects the BI buckets with the smallest available labels and allocates these for milking cow I. Please determine how many total buckets FJ would need to keep in the storage room in order to milk all the cows successfully. The first line of input contains N. The next N lines each describe one cow, containing the numbers SI, TI, and BI, separated by spaces. Both SI and TI are integers in the range 1 through 1,000, and BI is an integer in the range 1 through 10. And then we just need to output a single integer with the min buckets. And then we can see that this is the sample case. So what we can see about this is that, it's a pretty simple problem, right? All we need to do is just help Farmer John get his minimum amount of buckets he needs to use. Now, if you're confused, all the problem is asking you is the following, right? So we have all of our starting and ending times for different cows. So we can say that this is cow 1, 2, and then 3, right? So for cow 1, it goes from 2 to 6. Cow 2 goes from 4 to 10, and cow 3 goes 8 to 13. And each one has their own bucket values, or the amount of buckets they need while they're being milked. So 2, 1, and 3. Well, if we put this on a number line, we can see the following, right? So from 2 to 6, 2 buckets need to be used. From 4 to 10, 1, and then 8 to 13, 3. And during those times, there is some overlap in each of these, right? And this is where the complication of the min amount of buckets needed to be used comes in play, right? So let's take a look at from time 2 to time 10. Right, so we can see from times 2 to 6, cow 1 needs at least 2 buckets. But in between that time, at time 4, there's a new cow that's being milked. That new cow needs another bucket. These 2 buckets are already being used. As we can see, they're going to be stopped being used at time 6. Whereas the second cow now needs an additional bucket. That makes our total buckets equals 3. That is also our current amount of buckets being used. Next, we'll see that at time 6, these 2 buckets are no longer needed. So we can essentially remove it. So then our total go down to 1. Then at time 8, we can see a new cow is starting to be milked. And this new cow requires 3. So thus, the total then becomes 4. And then finally, at time 10, we lose a bucket because the second cow is done being milked. So now our total becomes 3. And then finally, at time 13, we return to our original state, which was total equals 0 buckets. Now, all we're doing is basically looking at our starting and end points. And at our starting points, we're adding to the total number of buckets. And our ending points, we're removing from the total buckets. So we can do the following. So at our time 2, it marks that this cow needs 2 buckets. Then our next smallest number will be 4. And this is a starting index, so we know 4 points to 1. So then we'll have 4 to 1. Then we have 6. 6 points to 2, but the thing is, 6 is an ending interval. So it should be removing buckets. Thus, 6 will be just the negative version. So 6 is -2. Then we see 8 starting, so then it will be positive. Then 10 ending, so it'll be negative. And then finally 13 ending, so it's negative. Now, all we need to do from here is just basically add all of these values and keep track at where the maximum value that occurs. So here, we could go through this, right? So first, these two add up, so it'll be 3. Then this product plus the next one add up, so then it'll be 1. Then these products add up, so it'll be 4, which in our simple solution was the max, and we'll see that this checks out because in our next one we subtract 1, so we'll go back to 3, and then finally subtract 3, and that will leave us with 0. So as we can see, the max amount of buckets we need is 4. And yeah, that's all you need to do for this problem. And it's quite simple because we know that there's at least going to be 1 cow being milked at any given interval, and that both the starting and ending times are distinct for each cow. So now we can just take a quick look at the code. And this code is pretty simple. First, we're just taking standard input, and then we're just creating the points that I mentioned earlier. So points start, right? So that would be 4, and then its value, which would be 1. And then end would just be 10, and then its value would be its negative version, right? So we'll just get a list of values the way it should be. So if we just print points, we can see, yeah, how everything is made. After we do that, we just want to sort everything, as we said before, by its starting, or by the from ascending order. So all we need to do for that is just do points.sort. But since we have tuples inside of our list, we just need a lambda function that will sort it based off its first value. So this is just the code for it. If you don't know it, you could always just search it up, or just search up a solution online, or you could just go through a for loop and do it like that. But this is just a one-liner solution for it. And what this is saying is that as it sorts, it'll be sorting by the first value, which would be these values. But in case if there are 2 values that are the same, so let's say this is 4 and 4, which will never occur in this problem because it states it. In case though, then it would just go off of the second value, which would just be like the amount of buckets you need. But that doesn't really matter for this problem. Next, we have max buckets because we want to keep track of our output. And then we have the current, which tells you the current amount of buckets at either the starting or end point. And then all we need to do is just go for point and then val inside of the point list to iterate through each of these, the values. And then we're just adding to the current value. And then we're checking, okay, if that current value is greater than the max value, then we just set the max value to the current value. And then we'll get the solution. So yeah, thank you for watching.